Today we're going to be looking at speed time graphs and what we can obtain from speed time graphs. So let's start off with how the speed time graph looks. So just like any graph, we have our y-axis. We also have our x-axis. So when we say the speed time graph, what happens is that on our y-axis, we have speed. So for instance, speed could be meters per second, or sometimes it can be kilometers per hour. No. The x-axis, this represents time. So the time here is usually in seconds or it can be in hours. So these are the typical standard units that are used for both speed and time. Meters per second, kilometers per hour, and seconds are hours. Now, we know that the gradient of a graph, so the gradient of a graph is equal to the change in y over the change in x. This is typically written as y2 take away y1 over x2 take away x1. But right now I want you to focus on the change in y over change in x. Why is that important? Because basically we are dividing the units on the y-axis, which in this case for instance would be meters per second, over the change in x, which units are seconds. So now meters per second divided by second would give us meters per second squared. Now if you just want to see the maths behind this, this is like saying meters per second divided by seconds. Now what do we do when we have a fraction? We keep this, we change this to multiplication, and we flip this. So then it's going to be 1 over s. We work it out. M times 1 is m over s times s, which is s squared. Therefore we have this unit here, which represents our units that we get when we calculate the gradient. So likewise, if we had to do it for kilometers per hour, we would have had kilometers per hour squared. Now, what do these represent? This represents acceleration. So therefore, if we were to calculate the gradient of a speed time graph, we would get acceleration. So the gradient of a speed time graph gives us acceleration, or the opposite of acceleration, which is deceleration. So the question is, how do we know the difference? We'll see that in a bit right now. So let's talk about this graph in itself. So usually you can have 3 different instances of how a speed time graph can progress for our understanding of this syllabus. So we can have it with a line ascending. When we have it ascending, we call this particular part here uniform acceleration. Why am I calling it uniform acceleration? Because it's ascending proportionally in a linear fashion. So speed versus time is increasing in a linear fashion. So this here is a uniform acceleration, and at this point the gradient or the acceleration is positive. So at this point the gradient is positive. So if the gradient represents acceleration and the gradient is positive when it's going up, we know that a positive gradient means that we are accelerating. So in this case we are actually accelerating. Now another condition is we can have a flat straight line here. At this point, what's happening to the speed? So the speed at this point is constant. So we have constant speed in this instance here. And if we have constant speed here, that means we are not accelerating. Remember, the whole idea of acceleration means that you're increasing speed over time. Just like someone who's just starting to run a race, you say on your mark, get set, go. As that person starts to run, they're starting to increase their speed every second. So that would be acceleration. Now when they hit their peak speed, then you'll see them cruising, which is constant speed. So I like to say that this part is when we're cruising. Okay, so at this point acceleration is 0. Now the next thing, we could have another phase like this. So this next stage is slowing down. So our speed, as you can see, the levels are decreasing over time. So it's decreasing. So for instance, if here was 10 meters per second, as we continue to go, you start to see the speed decrease. So at this point, we could say this is uniform deceleration. But when you get a question, they could still ask you acceleration, right? But in this case, we call it deceleration, right? So uniform deceleration, which we expect the gradient to be negative. So when we say positive and negative, we use numbers, right? So positive gradient. So when we say a positive gradient, we are talking about it being more than 0. It means the body is accelerating. So therefore, a negative gradient. So what is a negative gradient? Less than 0 means the body is decelerating. A gradient of 0 means the speed is constant. So these are the key things that we have here. So in summary, we say that a speed time graph has the speed on the y-axis, the time on the x-axis. The units, or the standard units, are meters per second squared, or kilometers per hour squared. We say that when we see a line going up and it's straight, we see that's a uniform acceleration. The gradient is positive, so we're actually speeding up at this point. If we see that the graph has a flat line here, we're saying that it has a constant speed, or the acceleration is 0. If we see it going down, we're saying that we have uniform deceleration and the gradient is negative. Another thing that we can get from the speed time graph is the distance traveled. Now, how does this work? So usually we could split this into sections. We can work out what we have, right? So this here is basically trapezium. So I'm gonna use this portion here where the body is at constant speed. So if this was a portion that we wanted to see the total distance traveled, how this works is, let's say for instance here was 10 meters per second, and then maybe between here we had something like 12 seconds and 8 seconds. So we are saying that the gap between here is what? 4 seconds. Now this here is 10 meters per second. So for instance, looking at this particular section, as we said, what if I was to calculate the area of that shape? I'm just saying I have this portion here with its constant speed. So the height of this from here to here is 10 meters per second, and from here to here is 4 seconds. Now how do I calculate the area of this? Now the area of a rectangle would be length times width. So I could say in this case it's going to be 10 meters per second times 4 seconds. So 10 times 4 is 40, and the units we are left with is meters per second times seconds. So let's break this down here. So we have meters per second multiplied by seconds. So seconds as a fraction would be s over 1. Now if we multiply this, remember we have a s on the bottom. S into itself goes once. S in the top, S into itself goes once. Alright, so therefore we'll be left with m over 1, or m. And what is m? M is the units for distance. So we are saying here that based off of this, if we work out the area, we would get 40 meters. So in essence, the area of this shape, any point to any point, so if I wanted to work out from this point to this point, the area here would give me the total distance. So that would be the total distance traveled. So I said portion because if you wanted to find the total distance traveled here, you could only find the area here. If you want to do it for here, likewise, same thing. So for instance, let's look at this part again. So this here, what shape do we have here? So we are saying that from here to here was 8 seconds, right? So this would have been starting at 0 and going to 8 seconds. And the top speed at this point was 10. So this shape here is a triangle. So we're saying from here to here is 8 seconds. Perpendicular height will give me 10 meters per second. Now, how do you find the area of a triangle? The area of a triangle is half base times height, perpendicular height. So in this case, it's going to be half times 8 times the height, which is 10. So half of 8 is 4 times 10, which is also 40 meters. Remember, the unit is going to give us the distance. So between these first 12 seconds, in this stage, we travel 40 meters, and in this stage, we travel 40 meters as well. Okay, so this is just a rough idea to give you an understanding of what we can get from speed time graph. So let's say now, from here to here was 14 seconds, so 12 to 14. Now we need to work out the area inside of this part here. So when I'm looking at this one, the height of that triangle goes straight up to 10 meters as well. So that's going to be 10 meters per second. And then from here to here, it's 12 seconds to 14 seconds. So what's the difference between 12 to 14 seconds? That's 2. So then now, I still have the same concept. Area is equal to half base times height. So I'm going to have half times 2 times 10. So half times 2 is 1 times 10 is 10 meters. So therefore here I travel 10 meters. Now based on what we did here, if I wanted to calculate the overall distance traveled for the entire journey, that would be equal to 40 plus 40 plus 10, which is 90 meters. So for this entire journey, we travel 90 meters. So that's how we can use that to find the distance. So now in some examples, we're going to look at how can we read data from a graph. So this here shows the movement of a 7-year-old running. So from the starting of a race to passing the finish line and slowing down. Alright, so we see here on our y-axis we have speed, And on our x-axis, we have time. So we know we're working with a speed time graph right here. Okay, so now we can look at the different stages now. And so we see a line increasing constantly and proportional relative to each other. So we know we have uniform acceleration here. So we expect our gradient here to be positive or more than 0. Here we have a flat line. So we know that at this point, it has to be what? Constant speed. So acceleration at this stage is 0. It's not accelerating. It's just maintaining its current speed. And at this phase, we see it's going down. So now that it's going down, what is happening? We are saying that it's decelerating. Okay, so it's decelerating. And when it's decelerating, the gradient is going down. We expect that the gradient is going to be negative. All right, so let's go through these questions here now. So the first question, what was the maximum speed throughout the journey? So if you look at the speeds that we have here, it goes straight up to 6. The highest speed that we reached in this case was on this line here, which would have been at 6 meters per second. And if you look at it, there's no other time that we surpass this speed. So the maximum speed throughout this journey from here to this point is just 6 meters per second. So number 2 says, during what time period was the 7-year-old accelerating? So acceleration from a speed time graph means that we would see the graph going up. So when it's going up, we know, that's when it was accelerating. So what time period was that? So that would be between here to here. So from 0 to 4 seconds. So 0 to 4 seconds, we would have seen that acceleration was taking place. So, third one, during what time period was the 7-year-old at constant speed? So, constant speed, we expect to see that no acceleration was taking place. So, therefore, no speed was increasing. So, at what time interval do you see speed was remaining constant? So, if you look at this, you realize that from 4 to 10, that's the only time speed is constant. So, 4 to 10 seconds was when speed was constant. So the next one says, during what time period was the 7-year-old decelerating? So deceleration means that it was slowing down. So as you can see here, we are seeing it coming down. So that means the speed is slowly coming down from 6 straight down to 0. So that time period is from 10 seconds to 16 seconds. Alright, so they tell us now to calculate the gradient from point B to point C. So this is point B here, and this is point C. So before we calculate the gradient, we need to know what is the gradient formula. So the gradient formula is change in y, so y2 take away y1 over x2 take away x1. So in order to do this, we need to figure out, first of all, what are our coordinates. So B is x-axis first, so 10, 6. So you see 10 on the x-axis, 6 on the y-axis. So 10, 6. Now C is right here, 16 on the x-axis and 0 on the y-axis. So we always put the x first. So then we say here now it's going to be x1, y1. I'm going to call this x2, y2. So now we can put this in my formula. So my formula here says y2, which is 0 take away 6. So y2 take away y1, which is 6, over x2, which is 16, take away 10. So 0 take away 6 is negative 6 over 16 take away 10, which is positive 4. So if I was to reduce this to its lowest form, we're essentially saying 2 into negative 6 goes negative 3 times, 2 into 4 goes twice. So negative 3 over 2 meters per second squared. So this negative sign that you see here is what indicates that it's slowing down. So it's slowing down its speed over time. If it was positive, like over here, we would see that it's increasing its speed over time. So what we calculated here was a gradient, and a gradient in the speed time graph is acceleration. And not only is it acceleration, remember once it's slowing down, we can refer to that as deceleration. So let's have a look at this now. We said, what is the maximum speed obtained during the graph through the journey? So remember when we looked at the last one, we said that the speed would be the highest point. So if you look at this, we go straight up to 15 meters per second, but we still go higher. For just a brief moment in time, we actually hit 25 meters per second. So that is the highest that we have have right here, that means our maximum speed was 25 meters per second. So now for number 2, state the number of seconds at which speed was constant. So when I have speed is constant, we are looking for flat line, because remember, constant speed means we are not speeding up, neither are we slowing down. So the only time that we have constant speed is from here to here. Now it asks us to state the number of seconds at which speed was constant. So we started off at 15 when it was 10 seconds and stopped at 20. So therefore 20 take away 10 means that we were at that speed for 10 seconds. Okay, so we stayed at this constant speed for 10 seconds. The third part, it says during what time period was the body decelerating? So we said that when it comes to decelerating, right? What happens when we're decelerating? So we start to see that it's going down. We're slowing down. So as you can see here, this is the only time period we slow down. So from 25 meters per second, we went straight down to 0. Okay, we went straight down to 0 at this point here. So we started to slow down at 30 seconds and we ended our slowing down process at 50 seconds. So from 30 to 50 seconds, the body was decelerating. Now for number 4, they're asking us what was the acceleration for the first 10 seconds. So how do we go about calculating acceleration? So when you're calculating acceleration basically means that we are looking for the gradient on the speed time graph during the point where it was accelerating. And when was it accelerating? For the first 10 seconds, right here, from here to here. Okay, so that's a period it was accelerating, the first 10 seconds. So when you look at this here now, we have a coordinate for this, which is 10, 15, and the coordinate here is going to be 0, 0. So I can call this x1 and call this one y1. This here is going to be x2 and here is going to be y2. Now why did I say that? Because we know that a gradient is a change in y, so y2 take away y1 over x2 take away x1. So in this instance, y2 is 15, so we say 15 take away x1, which is 0, over 10, which is x2, take away 0. So that's going to leave me with 15 over 10. In other words, this is the same as 5 into 15 goes 3 times, 5 into 10 goes twice. So we have 3 over 2 meters per second squared. So this is the same as 1.5 meters per second squared. So we are accelerating at this rate. So you can see here, this is positive, which we expect, because as we increase, we expect the speed to be increasing 1.5 meters per second every second. Alright, so the next one, number 5, was what was the acceleration between 20 and 30 seconds. 20 and 30 seconds. So from here to here, how can we calculate the acceleration? It boils down to finding the what? Correct, the gradient. So y2 take away y1 over x2 take away x1. So in this case here now, we say that this coordinate here is 20, 15, and this one over here is 30, 25. Okay, we no longer need these. I'm going to call this x1, this y1, this is going to be x2 and y2. So y2 take away y1 in this case is going to be 25 take away y1, which is 15, and that's going to go over 30 take away 20. So 25 take away 15 is 10, and then 30 take away 20 is 10. So 10 divided by 10, we know that this is basically 1. So we are saying that we have 1 meter per second squared. So our acceleration is 1 meter per second squared. So therefore, that is the acceleration at 20 to 30. Alright, so we're going to look back at an old familiar graph, and it says, what was the distance traveled for the first 0 to 4 seconds? Alright, so 0 to 4 seconds, and we're talking about a speed time graph. How do we go about calculating the distance using a speed time graph? We have to calculate the area in that particular region. So we have to calculate the area in this region right here. So 0 to 4 seconds. So we have here a triangle. So from here to here is 0 to 4. So 0 to 4, the difference between that is 4 seconds. And the height is what? 6 meters per second. So that's the max speed at this point, 6 meters per second. And I can use a triangle's area to work this out, because I know that this acceleration is constant. So the area for this is going to be half times base times height. So in other words, half multiplied by 4 times 6. So what's half of 4? Multiply that by 6, and we're going to get 12 meters per second. So we just worked out 12 meters. So the total distance traveled for this first one here is 12 meters. Now the next one, it says what was the distance traveled from 4 to 10 seconds? So from 4 to 10 seconds, what do we have here from 4 to 10 seconds? We have here a rectangle. So 4 to 10 seconds, the max height was 6 meters per second. So I can say here that from here to here is 6 meters per second. And from 4 to 10, what is 4 to 10? So the difference between 4 to 10 would be 10 take away 4, which is equal to 6 seconds. So I know that here is 6 seconds. Okay, so from 4 to 10 is 6 seconds. Now the area of a rectangle is simply length times width. So in this case, it's going to be 6 times 6, which is 36 meters. So the distance here is 36 meters. All right, so number 3, what was the distance traveled from 10 to 14 seconds? So 3, we have 10 to 14 seconds. We have again here, so yes, this was supposed to be 10 to 16. So we have 10 to 16 seconds. We want to figure out what is the distance traveled from 10 to 16. So if we're using a speed time graph, in order to figure out the distance, we have to calculate the area. And this shape here is a triangle. Now we know that the max height at this point went up to 6 meters per second. And we know that from here to here now is 10 to 16. So what is 10 to 16? So 16 take away 10 would give us 6. So we know that from here is 6 seconds. So 6 meters in height, 6 seconds in base. So the area of a triangle, half base times height, which is equal to half times 6 times 6. So what's half of 6? 3. And times 6 is 18. So 18 meters. 3 times 6 is 18 meters. In this stage, we covered 18 meters. All right, so number 4, what was the total distance traveled for the entire journey? So number 4 asks us to find the total distance traveled. So if I want to find the total distance traveled, I have to add up the distance covered in each stage. At each stage it was 12, then 36, then 18. So 12 plus 36 plus 18. So 18 plus 12 is 30. 30 plus 36 is 66. So 66 meters was my total distance traveled. My total distance traveled. Just a fun fact, remember that this full shape is a trapezium. So we could have used it as a trapezium as well. So let's just do the total distance if we didn't do that and we wanted to work out a trapezium. So we say this is a trapezium method here. So the full time period from here to here is 16. Okay, now our height is what? Our height is basically 6 from here to here. Perpendicular height is 6. Now between these 2 points here, so from 4 to 10 is how much? 10 take away 4 is 6. So we say that here is 6. Now the formula for a trapezium is half a plus b times height. And what does a plus b represent? The parallel components of the trapezium. So in this case, 6 and 16. And h represents the perpendicular height. So we'll have here 6 plus 16, and then we'll have multiplied by 6. So then we'll have half of 6 plus 16. 6 plus 16 is 22. We multiply that to 6. So what's half of 22? Half of 22 is 11. We multiply that by 6. That gives us 66 meters. So that's just showing you another way that you can do it. You could either calculate the area of the entire thing, so all this, or you could have walked it out piece by piece, then add them together. Now number 5, the last piece to the puzzle. So sometimes they may ask you, what was the average speed of the journey? So usually when we working out average speed, we usually just say the total distance traveled divided by the time taken. So I know that at different points of this journey, I was going faster than other times. So at this point, the young lad was 1 meter per second. Then out of a sudden, it was 6 meters per second. Then he started slowing down again. And it was a fluctuation between the two. So in order to work out the average speed, we need to know the total distance and the total time taken. So the total distance was 66 and the time taken was 16. So once we divide this by each other, we would get the average speed. So in this case, 66 divided by 16 is 4.125 meters per second. So this here is our average speed. Okay, that's our average speed for number 5. 4.125. Alright, so basically this is the general concepts that you would need to know when it relates to speed time graphs for Csec mathematics. So just go through this again. Make sure you grab all the components. The important part is knowing when is acceleration, when is deceleration, when is constant speed, what is maximum speed, how to calculate the total distance traveled between a given time period. So continue to work hard, continue to push yourself to get better at what you're doing. This ain't no play man thing. This is serious business. All the best.